Solve the following inequality. X squared minus 9x plus 20 over x squared plus 12x plus 36 is greater than or equal to 0. So first off, it's going to be best if we have this in factored form. So let's go ahead and take some time to factor the numerator and denominator. Alright, so the numerator should factor into, because I have a 20 here, I should be able to factor that into 5 and 4. And if they're both negative, they multiply to positive 20 and add to negative 9. Then the denominator for 36, I could use 6 and 6. And since those are, if those are both positive, then they would add to 12. So that's great. So actually, an easier way to think about this would be x minus 5 times x minus 4 all over x plus 6 quantity squared is greater than or equal to 0. Now, to begin, what we have to do is identify the zeros. So the zeros matter if they're in the numerator or if they're in the denominator. So I'm going to just list them separately. The zeros of the numerator, I just take the individual factors, set them to 0, and solve. So 5 and 4 are the zeros of the numerator. And if I take x plus 6, set that to 0, I get negative 6 as the 0 of the denominator. Now, what's important about that 0 in the denominator is it's an asymptote. No matter what, I cannot include it as part of my final answer. So what I'm going to do to start off is put each of these zeros on a number line, just like if this was a polynomial inequality. They need to go in numeric order. So negative 6 is the smallest, and then 4, and then 5. Now, no matter what, because negative 6 is a 0 of the denominator, it cannot be included in the final answer. So I'm going to go ahead and circle that and just put an open circle for it. But the final answer, I want values that are greater than or equal to 0. So the polynomial would be equal to 0 when the numerator is 0. So these values are fine and would be included in the final answer. Now what I need to do is just pick some test values here and see what's happening in between the zeros. So negative 7, for instance, 0 would work on this interval, 4.5 would work here, and say 6. And now what do I do with these values is go through and see where the polynomial is positive and where it's negative, or the rational, that is. Now, in the denominator, what's interesting there is anything that I put in for x plus 6 quantity squared is always going to result in a positive value. So I really don't need to think about that when it comes to determining which values are positive and which ones are negative, because dividing by a positive is never going to change the sign of an answer. So I can leave that out to simplify things. All right, so negative 7 minus 5 would be a negative value. It doesn't matter what it is, it's just that it's negative. Negative 7 minus 4 is also negative, so the result here is everything on this interval is going to be positive. On this interval, 0 minus 5 is negative, 0 minus 4 is also negative, so everything on this interval is positive. At 4.5, 4.5 minus 5 is negative, 4.5 minus 4 is positive, so everything on this interval is negative. And at 6, 6 minus 5 is 1, so that's positive. 6 minus 4 is also positive. So a positive times a positive is positive. Now I'm looking for things that are greater than 0, and so I'm looking for all the positive cases. So that's that interval, and this interval right here. And the last set here is also positive, so I will shade that. And then we'll give the final answer, which is all the values from negative infinity to negative 6, but not including negative 6 because it's that asymptote. And then starting from negative 6 and going to positive 4, but we include the positive 4. Then going from 5 to positive infinity.